Good afternoon, ladies and gentlemen, boys and girls. You should have watched Unit 1, Lesson 2 lesson, and today we're going to talk about Unit 1, Lesson 2 activity. And this will be an important activity. There's some problems addressed in this activity that was not addressed in the particular lesson. So number one here, we're going to find the x and y intercepts of the following and label them as points. Then we're going to give a rough sketch of the equation on the grid below. So if I look at number A, the first thing we're going to do is we're going to find the x-intercepts. How do I find the x-intercepts? I let y equal 0. And let's do this, all right? Let's actually state what we're going to do. We're going to find the x-intercepts. And how are we going to find the x-intercepts? We're going to let y equal 0. And if I let y equal 0 into this equation here, I'm going to end up with simply 2x squared is equal to 32. And that's why I wrote 13, sorry. It's equal to 32. If I divide both sides by 2, I get x squared is equal to 16. And keep in mind, if I take the square root of 16, it's the absolute value of x. If I square root both sides, so that is going to give me x is going to be 4. Don't forget that x is equal to negative 4 as well. Negative 4 squared is 16, and 4 squared is 16. So my x-intercepts then are these 2 points, 4, 0, and negative 4, 0. Okay? And let's see if we have enough room, and we do. We're going to find the y-intercepts. Let me just do a dotted line here to keep these two problems separated. And let's find the y-intercepts. We're going to find the y-intercepts. How are we going to find the y-intercepts? We're going to let x equal 0. And if I let x equal 0, what equation will I have? Let's see here. I want to have room to graph the... If I let x equal 0, what am I going to have? I'm going to have y squared. Let's put a line here. X equals 0, y squared is equal to 32. And that says y is going to equal positive square root of 32 and negative square root of 32. Okay? All right, that's okay. And if I notice, those simplified, 32 is 16 times 2. So this is going to be the square root of 16 times the square root of 2, which is going to be 4 square root of 2. And this is going to be negative 4 square root of 2. And golly gee, I've just messed things up completely. And I apologize. Hopefully I will be able to recuperate. And this is going to be negative 4 square root of 2. And all we need to know is that those, so therefore my y-intercepts are going to be, my y-intercepts will be 0, 4 square root of 2 and 0, negative 4 square root of 2. So those are my y-intercepts, and it looks like we're really short on space here. But so we want to graph these 4 points. I have this point, this point, this point, and this point. All I know is that 4 square root of 2 is a little bit over 4. So I'm going to plot my x-intercepts first. We're just going to let that guy right there be 4, 0, and this is going to be negative 4, 0. And then all we know is that these blue points are a little bit more. So we're going to sketch those, and this is going to be 0, 4 square root of 2. Sorry. 4 square root of 2, and this is going to be 0, negative 4 square root of 2. And if I do a rough sketch, this is what we call an ellipse that we really didn't talk about in Algebra 2. And do you really need to know what an ellipse is? Nope. What you really just need to be able to do for this assignment is to be able to find the x and y-intercepts. How do you find the x? By letting y equal 0. How do you find the y? By letting x equal 0. So not a whole lot of room there for that particular problem. So let's keep that problem here. And now I want to find the same thing with this activity. I'm going to find the x-intercepts. And how do I find the x-intercepts? I let y equal 0. And if I notice in this equation, if I let y equal 0, I simply have x is equal to 3 times negative 6. 0 plus 3 is 3. 0 minus 6 is negative 6. So the x-intercept is going to be negative 18. And that point then is going to be negative 18 comma 0. And if I want to find the y-intercepts, I'm going to come down here. And if I find the y-intercept, I'm going to let x equal 0. And if I let x equal 0, I have this quadratic I'm solving. Y plus 3, y minus 6. And we learned from our review section that a solution to this particular equation is going to be y is negative 3 and y is 6. And y is equal to 6. Therefore, my y-intercepts are going to be 0, 3 and 0, negative 6. Or 0, negative 3. I had that mixed up. And 0, 6. And so we're going to plot those. And plot those points there. I have negative 18, 0. It's certainly not going to be to scale. This is going to be negative 18, 0. And I'm going to plot this 0, negative 3, which is here. And 0, 6, which is up here. And this is a parabola that is opening to the right. And it will be symmetric with respect to the y-intercept. So this graph, again, it's going to have a minimum somewhere right smack in the middle of those two intercepts there. And that would be, and keep in mind that that graph goes on forever, that direction. Okay? So what's important here is knowing how to find the x-intercept, let y equal 0. Knowing how to find the y-intercept by letting x equal 0. Here's a good problem here. Find the x and y-intercepts of this particular rational creature here. We did a little bit of this in Algebra 2. So the y-intercept, I'm going to do this because that's going to be, first of all, the easiest thing. Let's get this thing out of here. Get him out of there. The y-intercepts is going to be easiest, so we're going to do that first. We're going to let the y-intercept, we're going to find the y-intercept. And how we find the y-intercept, we're going to let x equal 0. And if I let x equal 0 on this equation, it looks like I'm going to have negative 5 over 3. 0 minus 5 is negative 5. 0 plus 3 is 3. So this is the y-intercept is going to be 0, negative 5/3. Okay. This is the point. And now if I want to find the x-intercept, I'm going to let y equal 0 here. And so I have this guy right here. 2x minus 5 over x plus 3. And what we need to realize here, well, we could, so if I have an x-intercept, y is going to be 0. X is not going to be negative 3. So I'm going to multiply both sides because what I want to do is I want to solve this equation for x. I'm going to solve this equation for x. And one thing I can think about, when is a fraction 0? When is a fraction 0? A fraction is going to be 0 when the top is 0. Another way I could think about it is just do it analytically. If I can multiply both sides by x plus 3, oh, what happens? These things cancel, and x plus 3 times 0 is simply 0. And so if I want to find when this fraction here is equal to 0, it's only 0 when the top is 0. And when is the top 0? If I subtract 5, that's going to be when negative 5 is equal to 2x. And which says that negative 5 halves is equal to x. And that's my y-intercept then is going to be negative 5 halves, 0. Okay? Now these particular problems here, and keep in mind you can always pause the video. You're supposed to pause the video. if I'm going to symmetric and I'm looking at my notes and I'm referring back to the video on the lesson 2, if I want a point with respect to the x-axis, what happens is the x's remain the same and the y's change. So this is going to be -8, or get a pen here, -8, -8, comma, -17. And I'm going to go right down the line. This is going to be 5. Hey, what's the opposite of 0? 0. And this is going to be 12. What's the opposite of -5 is 5. So the x's remain the same and the y's go opposite. So the x's remain the same and the y's go opposite if you're reflecting across the x-axis. If you're reflecting across the y-axis, the y's stay the same and the x's go opposite. X's go opposite, the y's remain the same. The x's go opposite, the y's remain the same. And if I recall from lesson 2 about symmetry with respect to the origin, the x go opposite and the y's go opposite. So this dude right here, these points are going to be -8, pardon me, 8, -17, because I'm going to go the opposite of the original point. This is going to be -5, the opposite of 0 is 0. And the opposite of -12, the opposite of -5 is +5. So that's those points, pretty easy creature right there. And now we're going to use that, and we're going to come down here and we're going to do some reflections here. We're going to consider the graph of Bob, which is an arc EF. That's the graph of Bob. So we're going to call him Bob. And we're going to label those points. I'm going to find out what the coordinates of E and F are. Well, the coordinates of E are 1, 2, 3, 4, 5, 6, 7. This point right here is 7, 3. And this point right here, F, is 3, 7. And we can see it's arced. So this is 3, 7. 1, 2, 3, 4, 5. This is about a 5. This is not 7, this is 5. 3, 1, 2, 3, 4, 5. This is 3, 5. So I have 7, 1, 2, 3, 4, 5, 4, 5, 6, 7. It's close enough. 7, 3, 1, 2, 3, and 3, 5. And now what I want to do is I want to sketch the image of Bob, symmetric with respect to the x-axis. So I'm going to flip that rascal about the x-axis. And if I recall what I just did, the x's remain the same and the y's change. So I want the point 3, -5. 1, 2, 3, 4, 5. This is that point 3, -5. And what do I want? The x's remain the same and the y's go opposite. So I'm still here, but I want to go to 3. So this point is going to be 7, -3. And this is going to be the reflection of Bob about the x-axis. We're going to color him in blue. And it's going to have to be curved. And this guy right here is Jamal. We're going to call this guy Jamal. Now we're going to take the image of Bob. And we're going to reflect Bob about the y-axis. And we're going to call that rascal Jose. So what happens when I reflect across the y-axis? The y's stay the same, but the x's change. So this is going to be -3, 5. It's going to be about right here, -3, 5. The x's go negative. 1, 2, 3, 4, 5, 6, 2, 4, 6, 7, and up to 3. So this is going to be -7, 3. And so this is going to be the graph of Jose. Okay. And now I want to sketch the image of Bob that has origin symmetry. And origin symmetry is 180-degree rotational symmetry. But all I need to know is that both of the coordinates change their sign. So I'm going to go to, let's see, what color do we want to use? I'll just use this funky purple color, and I'm going to go to -3, -5, 1, 2, 3, 4, 5, and it's going to be right here. This is -3, -5, and keep in mind that is this point right here, both opposites. And so now I'm going to go -7, -3, -7, -3, and I'm going to make sure that my graph is arced between those 2 points. And this is the image of Susie. I call him Susie right there. Okay. So there will be an assignment that's similar to that. Keep in mind you can pause the video, short video for this activity, and thank you very much, and we will